Hello, welcome to the Machine Learning at Home. As promised, I today will show another method to work with neural gas. So, to remind you, neural gas is a method of employing artificial neural network for classification purposes. So, working well for many clusterization tasks. And neural gas is implemented in R in several different ways. So, second way to use the neural gas is from the package FlexClust. So, library FlexClust. Okay, as you see, it loads quite a lot of packages, and importantly, it will load stats4 package. So, approach to which FlexClust use its multiple object is slightly different from a base R, but it's useful to know how these packages are working as well. So very easy is to run the neural gas approach. So take the iris data and then apply command ccclust. And then that ccclust will require, of course, not the whole data, but only data without fifth column. And we also must specify the number of wanted clusters, which is 3 because there are 3 species, and also specify the method because there are multiple methods embedded in this command. So method equal to neural gas. And of course everything should be in some object. For example, iris.ng for neural gas. Okay, now we can run it. And as nothing appearing, everything went well. So now how to approach results. Iris.ng is a complicated object. It contains multiple so-called sockets, and we can access any socket, for example, socket which inform us about clusters, with @ sign. So we can, for example, type iris.ng, then @ and cluster. And you will see that objects are classified as we wanted, exactly into 3 clusters. So how to approach this classification? One of typical ways which I use myself is loading my package, Shipunov, and then use misclassification confusion matrix. So misclass, and then we use this iris.ng cluster, and then we use initial iris species. In that case we use $sign, not @, more normal for R species. And also must specify best equal to true. And then we'll see what's going on. Well, I would say results are very good, very honest results, about 11% of misclassification error, and as usual one of species, in that case Virginica, is not going very well. Other species, by the way, versicolor is much better. So let us visualize what we see. We can use plot function directly with more or less complicated content, but I will type it in one string, and you will probably understand quite easy what I did. So for example, we use prcomp as a function to arrange our dots in 2-dimensional space. So dots will come from iris without fifth column data as usual, and we need only X component. And then we use for colorizing iris dot $sign, species, and for shape of dots we will use number of cluster number from our neural gas classification. So PCH equal to for example, iris ng, and then @sign cluster. Okay, well, it's not so complicated. I hope it's understandable. The only thing I need to remember if I put every parenthesis in order. Looks like I did. Remove the fifth column, and otherwise everything looks normal. All parentheses are in place, and we can make a plot. Okay, so you see the plot now, and probably this is again very decent plot which shows exactly what we observed in misclassification matrix. As you see here, so as you see, among red species most are circles, whereas some of them, just two as I can see, right, are in crosses, whereas in green species most of them are crosses, and well, I would say many of them, much worse in that case, are circles. So exactly what we saw in confusion matrix. But method is reliable, not worse, not much better, but not much worse than anything else, and you can use neural gas for your classification purposes, like one of interesting clustering methods which works quite well. So again, this was a neural gas in another way with the package FlexClust. Thank you very much.